Okay guys, welcome back. So in the last video I talked to you about a solution, actually two solutions on limits. So in the last video we talked about the limit, how to find the limits of trigonometric functions. I explained to you about the limit of sine x by the limit when x goes to 0 for sine x by x, which is equal to 1, and explained to you about two similar examples. So in this video I'll be talking about two applications in which the substitution is necessary to find the limit of a given function. So I'll take the first example like this. Take the limit when x goes to 5 by 2, 2x minus 5 by cos x, right, by cos x. So this is the limit I am going to find today. Alright, in the first example of this video, and I will present you with another example as the second part of the video. Alright, so how we can solve this problem? So it's somewhat a complex problem for some students, and some students have been struggling and explaining to me as to how to find the limits using substitution. And in this video, that's the main reason as to why I produced this video. So in order to find this limit or any limit using substitution, you need to know what is the term that you are going to substitute. What is the term you are going to substitute, and why do you need to substitute? So for finding the term that you need to substitute originates from the concept that why you need to substitute. Now if you are given some function like this, limit of 2x minus 5 divided by cos x when x goes to 5 by 2, how can we solve this? Right, first in the place we'll just substitute 5 by 2 in place of x and see what happens. Now if you substitute 5 by 2 here, you will get 2 times 5 by 2, which is 5. So 5 minus 5 is 0, so the numerator is 0. And for x here, if you substitute 5 by 2, cos 5 by 2 is again 0. So the numerator is 0 and the denominator is 0, but we don't normally we think it is meaningless, a quantity of 0 divided by 0. So you can't directly find the limit of this function. So that's the first thing you need to know. Alright, the second thing, now you know only about sequences in which the limit, you can find the limit of sine x by x when x goes to 0, and that is equal to 1, right? That's a theory, and in the last video I explained to you about two similar examples. Now you got cos x here, you have no sine x's here, and in the numerator also you can isolate x. Although you divide like this, right? Although you divide 2x by cos 6, you don't know, right? You don't have any opportunities, so you don't have any options in order to form sin x by x. So that's the second reason as to why you need to go to substitution. So due to these two reasons, you need to go to substitution. And the next problem is, what is the term that you are going to substitute? Alright, so you know that when some function, say x or y or z, now in this case the x, right, x goes to 0, sin x by x is equal to 1 when x is measured in radians. Alright, so that's the definition. But here you have been given that this is when the limit is taken when x goes to 5 by 2. So when x goes to 5 by 2, this doesn't, what is the answer of this? That's the question. So you can only put the theorem. Now this is first of all you need to understand that this is a trigonometric relationship, right? Without substituting either for cos x or converting this to sin x, right, using a direct substitution in place of cos x, or converting this cos x to sin x by somehow, you cannot solve this equation. Those are the only two options you have to solve this equation. So either to completely substitute some function in place of cos x, or to remove cos x and place sin x somehow by some substitution either to the angle or as the coefficient of cos x, and then turn into sin x. Those are the two only options. So in order to do that, that's one way of thinking about the term of substitution. And the other way, as I mentioned a little while ago, is that if you are going to put the theorem of limit when x goes to 0, sin x by x when x is measured in radians is equal to 1, you need to have here 0, right? So that is the method actually I'm going to do this, because using a direct substitution for in place of cos x is okay, but I think it's some complicated, right? Complicated and time consuming. So I want to talk to you about some simple steps and simple examples how we can solve it very easily. Alright, so what actually happens is that now when x goes to 5 by 2, you have to find this. Now you have to convert this limit into a solution in which x goes to 0. But now actually you can't convert this into x into 0, because you have already been given that x goes to 5 by 2. So the only option that is available for you is that you have to convert this somehow x into another function, right? I'll take the function to be something like t. So you know that if some function like this, when x goes to 5 by 2, right, some function like t goes to 0, right, t goes to 0. So this is the theorem here. This is my argument. When x goes to 5 by 2, if t goes to 0, t or some other function or constant goes to 0, and if I can substitute that t goes to 0 in place of x goes to 5 by 2 here, I can easily change this whole function into a form of t and then solve, and then substitute the value of t for x, and then give the answer in the form of x's. Alright. So what actually happens is that when x goes to 5 by 2, in order t to go for 0, what actually happens is that t should be equal to x minus 5 by 2. Here if you subtract 5 by 2 from both sides, this will be 0. So x minus 5 by 2 goes to 0, t goes to 0. So for both right hand sides are equal, so t should be equal to x minus 5 by 2. T is equal to x minus 5 by 2. Right, so that is the substitution I'm going to do here. So I explain as to why I took that, right? So what actually happens is that now I have to substitute all the values of x in place of t. So if t is equal to x minus 5 by 2, you can say that x is equal to t plus 5 by 2, right? So you can directly substitute t goes to 0 here, and for x's here and here you can substitute x equals t plus 5 by 2. So I substitute that. So the next step of this one is the limit when t goes to 0. So 2 times x. So 2 times x here is you get 2t plus 2t plus, so 2 times 5 by 2 is 5, and here you get another 5, and in place of cos x you get cos 5 by 2 plus t, right? Cos 5 by 2 plus t. So this 5 to this 5 cancelled, this 5 to this 5 cancelled, right? So what remains here is 2t. It's 2t, so I can take this 2 out of here, because you know that you can take a constant out of this. So this is equal to 2 times the limit when t goes to 0, t divided by, you know that cos 5 by 2 plus something is sine that angle, but you get a minus here. So cos 5 by 2 plus t is equal to minus sine t. So this is minus sine t, right? Minus sine t. So plus divided by minus is minus. So this is also equal to minus t by sine t. So you can take the minus is actually minus 1 here. So you can take minus 1 here and you can multiply it here. So that will be 2 times minus 1, which is minus 2. It is minus 2 limit when t goes to 0, right? T goes to 0, t by sin t, t by sin t. So what I'll do is that now I know that when limit t goes to 0, sin t by t is equal to 1. So what I'll do is I'll divide both sides by t. So that will be is 2 limit t goes to 0, 1 upon sin t by t. So you can take the limit of the numerator as well as the limit of the denominator. So when the limit t goes to 0, 1 will be 1, and when limit t goes to 0, sin t by t will be equal to also 1. So the numerator will be 1, the denominator is also 1, so 1 divided by 1 is again 1, that multiplied by minus 2 is finally minus 2. Now the substitution. Now since you have not got any x's here, x or multiple of power of x squared or x cube or even x to the power 1000, right? A power of x here, you don't have to substitute the value of t in place of x. So what actually happens is that if you get something, this is minus 2 or something like this is a constant. But if you get some some t function here, so t is a function that you have taken solve this in the at the beginning of this sum, the value of t was not given. So what actually happens is that you have directly substitute x minus 5 by 2 in place of t, and then solve to get the value, the function, the solution of this problem in place of x, right? In the case of x, all right. So that's just a simple example. So let's take another example to elaborate, to find the limit using substitution. So this will be a complex example, but it's very simple, right? Seems to be complex when you'll see that. Seems to be complex, but when you solve that, you will see it's one of the easiest. So let's do something like this. The limit of this function x times 1 minus x times 1 minus root 1 minus x squared divide by root 1 minus x squared times sin inverse x cube, something like this. Alright, so I'll take the limit of x to be 0 now. Now the limit of x is 0, right? X goes to 0. So what actually happens, first of all, we'll substitute 0 in place of x and see what happens. Now if you substitute 0 in place of x, you know that x squared is equal to 0, right? X squared is 0, so 1 minus 0 is 1, so the root of 1 is 1. So 1 minus 1 is 0, and here is 0, so 0 times 0 is 0. So the numerator will be 0. In the denominator, when x is 0, 1 minus 0 is 0, and 1 minus 0 is 1. So the root of 1 is 1. So multiplying 1 by this one is the same of this one. So the numerator will solve to sin inverse x is 0. So sin inverse 0 is 0. That cube is 0. 0 multiplied by 1 is 0. So the numerator is 0, the denominator is 0. So as in the last case, we can say that when the numerator and the denominator are both 0, that is meaningless. So we don't define that. So you can't solve this using this. Furthermore, you don't have equations or theorems to solve sin inverse x. You know how to solve sin x, but you don't have theorems or laws or something like that to differentiate what is meant by sin inverse x. So what I'm going to do here is my substitution is that to remove sin inverse x. Now if you have cos x or tan x, you can simply translate them, transform them into sin x using Pythagorean identities or any other trigonometric functions. So that's if we have sin x, but if you have sin inverse x, the only possible option is to find the angle and then convert. So my substitution will be so as to remove sin inverse x with an angle. So I'll take the substitution like this. Take the substitution t to be sin inverse x. t to be sine inverse x. So if t is equal to sine inverse x, you can say sine t is equal to x. So what I will do here is that now when x goes to 0, when x goes to 0, when x goes to 0, sine inverse 0 is 0, so t goes to 0. Right? So I can substitute t goes to 0 in place of x goes to 0 here. Sine inverse x is equal to t, and I can substitute the value of x, sine t in place of x's here and here and also here. Right? Okay. So the next step would be is equal to limit when t goes to 0. So x is equal to sine t now. Sine t 1 minus excuse me 1 minus, so here will be now x is equal to sine t. So x is equal to sine t means that if you substitute the value of sine t here, 1 minus sine square t will be cos square t, and the root of that will be cos t. So here will be 1 minus cos t right, 1 minus cos t divided by, so again here 1 minus x squared is 1 minus sine square t, which is cos square t, and the root of that is cos t. So here will be cos t, and you know that's our substitution, sine inverse x is equal to t. So it will be t, right? It will be t. So what actually happens is that now you can say, now this is sine t here, you got a sine t here, and you got a t here, and you got limit t goes to 0, so that is directly 1. So what I'll do is I'll isolate these two terms with this limit, and this term and this term, this whole term within the bracket, and this term with this limit. Alright, so this is also equal to limit when t goes to 0, sine t by t times the limit when t goes to 0. So 1 minus cos t, here will be 1 minus cos t by cos t. So 1 minus cos t by cos t is equal to 1 upon cos t minus cos t by cos t is 1. So that will be 1 upon cos t minus 1. Right? So that's simple. So this is equal to 1. Right? Limit of sine t by t when t goes to 0 is equal to 1 times this is also equal to limit of when t goes to 0, 1 upon cos t. So whether t goes to 0 or not, t goes to any value, limit t goes to 0, 1 is equal to of 1 is equal to minus 1. So here will be minus 1 like this. So what actually happens is that you can write a substitute here is equal to, finally you will get that this is equal to yeah. So this will be equal to, what actually happens is that I think there's some problem here. Yeah. Is equal to 0. I think there's some problem here. Oops, sorry, I got a t cube here, right? So this will be t cube, right? Sorry, I got a t cube here. So what actually happens is there's a t squared here. So what I will do here is that I will not substitute like this. I will not substitute like this. I will solve it for the trigonometric terms. That was a careless mistake, sorry, right? So what actually happens is that the limit of when t goes to 0, sine t by t, right, sine t by t times, so I can say this to be the limit of when t goes to 0, 1 upon cos t times 1 minus cos t is equal to 2 times sine squared t by 2. 2 times sine squared t by 2. So here will be the limit when t goes to 0. T goes to 0. 2 sine squared t by 2 divided by t squared. So this is 1, right? This is 1. This is 1, and when limit when t goes to 0, this will be also 1. So 1 times this one is equal to this one. So this is now equal to limit when t goes to 0. So I'll take the 2 out as well. I'll take this 2, right? I'll take this 2 out here. Will be sine squared t by 2 divided by t squared. So I can write this sine squared t by 2 as sine t by 2 divided by t times sine t by 2 divided by t. So this is also equal to 2 times limit t into 0. So I'll take the individual functions. I'll write 2 steps at once. So this will be sine t by 2 divided by t times the limit when t goes to 0, sine t by 2 divided by t, right, divided by t. So in order to find this, now you know when t goes to 0, t by 2 also goes to 0. So in order to apply this equation, you have to have t by 2 here. So what I'll do is I'll divide by 2 and multiply by 2. So my final answer will be times limit, so that goes to 0, t by 2, t by 2 multiplied by half, right, multiplied by half. So that's this term times limit when t by 2 goes to 0, sine t by 2 divided by t by 2 times half, right, times half. So what you will get here is that this is 2 times half times half. So I take this half out here and this half out here times the limit when t by 2 goes to 0, sine t by 2 divided by t by 2 is equal to 1 times again here will be 1. So 2 times half is half, 2 times half is 1, 1 times half is half, half times 1 is again half. So the final answer will be half. Right? So the final answer will be half. So I'm extremely sorry that I didn't recognize that t cube, right? So, and I had to solve it to 0, right? I'm extremely sorry for that. So what actually happens is that you will get such an answer, half. Alright. So in this video, my actual objective of this video was that some students had problems of using substitution for limits. So in this video, I talked about the basic concepts as to how limits occur. Actually how substitution occurs in limits, why substitution is important, how substitution can be done, and where you can substitute. Alright, so in this video I talked about all those. So in the next video I'll be talking about some other topic, in the topics of calculus. Calculus means limits, differentiation and integration. I'll talk about another topic, and thanks for watching this video and see you then.